In this video, we're going to go ahead and start the subunit 10.2, Introduction to Conics, starting with parabolas. This is going to be part of Unit 10, Topics in Analytic Geometry. Okay, so what is a conic? Here's a definition. Conic section, otherwise known as a conic with an I. It's the intersection of a plane and a double napped cone. So I have a few pictures here to maybe kind of show you what it looks like. But basically, what it is, it's you kind of imagine these figures, so like these cones that are like kind of like back to back, but upside down. One's right side up, one's upside down, and you're like cutting a slice through it. And that slice that you're going through it, that's the actual plane. So think of like a just a flat plane that's going through it, and the figure that it makes inside the conic, I'm sorry, inside the cone, that's what we consider to be the conic section. In this case, in the first one, you'll notice that if I take a plane or a flat surface and just slice it right through, the piece inside the cone is a circle. If this is perfectly flat, it's not an angle or any of that sort. So the circle is all the points are equidistant from some point in the middle, which we know as the radius, right? And that's a circle. That's how we get a circle. We also have an ellipse, which is basically the same type of deal, but now we're going to, instead of making it flat, we're going to cut it through at an angle, and that makes an ellipse. So it's kind of like an oval, so to speak, like a squish circle from one side. Yeah. We have a parabola, which we are familiar with. This is a plane that gets put in kind of diagonally, but at the top. So you're just going to do the top part of the cone, or you could do the bottom too, but either one. And we're just going to get that top piece. So we have a parabola. And then you have a hyperbola, which is getting the plane and kind of putting it on the side. So if you could imagine two cones in this setup and then slicing it through from this top part up. So you're kind of thinking like right here, the edge, almost the edge of the cone, and just slicing right through it all the way to the bottom. Well, we would have these two almost parabola looking shapes, but one on both sides, right? So that's called a hyperbola. This first section is going to focus on the parabola. The circle, by the way, we have already seen, so we're not going to really focus on that one too much, but I will reference it here and there. Okay. We also have a degenerate conic, which passes through the vertex. I didn't draw these. I didn't want to make you draw them. We're not going to focus too much on them, but if you're interested in what they look like, this is the page number to look in your textbook. Basically, it would be going through the middle. So like through here, slanted through here. This one I believe is kind of like a weird, yeah, so that it's just a different interpretation of this, where when you do it, you actually end up with a point or a line or something a lot more basic than an actual shape. Okay. So let's look at the definition of a parabola as it is with a conic. Yeah, because we know that a parabola is like y equals ax squared plus bx plus c, but that's one version of looking at it. In this one, orientation does not matter, which means that we're not necessarily identifying if it's a function or not. We can have a sideways parabola, which is kind of cool. Yeah. So here we go. A parabola is the set of all points, x and y, in a plane that are equidistant. There's that word again, equidistant, from a fixed line, which we know as the directrix. It's called the directrix. Here's a picture, by the way, and a fixed point, which is called the focus, that are not on the line. So in other words, and let me keep reading. I'll show it to you right now. The vertex is the middle of those two. So it's the midpoint between the focus and the directrix. The axis of this parabola is basically the line going through the focus and the vertex. So here is an image of what I'm talking about. I'm going to zoom in on this part here because this is what a lot of our focus is going to be on today. And it looks like the following. You'll have a parabola, and there is this line either below it or above it, depending on where the parabola is facing. But there is this line that is called the directrix, and it is a distance away from the vertex, the same distance as this other point called the focus. And what happens is, no matter what point I pick on this parabola, the distance from this point to my directrix will always be the same as the distance from my points to the focus. So you have kind of like these equidistant points, and every single point on this parabola has that relationship. So if I were to pick, let's say, a point over here, well, the distance from this point to my directrix, we're going to call it D3, just because we already have D1 and D2, would be the same distance to this focus point right here. So this is the same, this distance is the same as that. And that works for the entire parabola. So if we put all those points together, which there's an infinite amount, we get the parabola. And that's what these things are representing, okay? So just like a circle where you have points that are equidistant from the center to the edge, in this case we have points that are equidistant from my parabola to the directrix and the focus. Okay, and also just so we know, this distance right here, well, this would be considered the same distance from, here to my directrix. So therefore, the one from here to the focus is also the same, and they line up perfectly. Yeah. So if you know what the focus is, you can find the directrix by just adding or subtracting whatever the space is here between here and here. And I forgot to label this, but this right here is the vertex. Okay. And then, of course, the axis is the line that goes through the vertex. And, in turn, the focus, because the focus is right on top of the vertex. Okay. Let's look at some more definitions. This one is going to have quite a bit of definitions before we do an actual example. Um, we have the standard equation of a parabola whose vertex is at hk, and that's not any different from what we've seen already before. If the parabola is vertical, and I should have kind of separated this right here, if the parabola is a vertical parabola, meaning it's the one we're used to that goes either up or down, then we have that the directrix is equal to y is equal to k minus p, where k is part of the vertex, okay? The equation for something like that looks like this. You have x minus h squared, which we've kind of seen before, but then you have this other thing over here, 4p times y minus k. And we do leave it in this form. This is considered the standard form of the equation. So we leave it like this because it's easier to see the vertex from here, okay? Where p is not equal to 0. P is that it represents the distance between, it's called the directed distance, okay? But P represents the distance between the vertex and the focus, and therefore the vertex and the directrix as well. We have something similar on this side, and I'll zoom out right now so you can copy it with a horizontal axis. So in this one, the parabola will go sideways, and you have x is equal to h minus p. So it's like the vertex plus or minus the p, depending what your distance is. And of course, instead of it being x minus h, now we have y minus k, because this one is going sideways. So these just kind of swap places a little bit. You can kind of mix them out a little bit so you can see the entire thing here. You'll notice that these are pretty similar, but now we have, these two swap places. And of course, we do have our p times 4, which gives us the other part of this equation. What is p? Well, p is the directed distance, okay, between the focus and the vertex. If the vertex is at the origin, so you're thinking 0, 0, then the equation is a little bit easier. Basically, this becomes this because, well, there's no more h and there's no more k. So therefore, x squared is just equal to 4p times y. Same with this side. If there is no k or h, then those go away and we're left with y squared equals the following. Okay. And then down here, I just have a few more images that I would like you to copy because they're going to help you with some of the problems. If we have, let's look at this side first. These are going to be the vertical examples that we have. We can have the parabola going up like this, where your focus is on top. So it would be basically your vertex plus your vertex, and then the y value would be that vertex plus whatever the p value is. So the distance, yeah. And direction is the same, but subtracting. And this is the format of your equation. If the parabola is going downward, well, then it's kind of the same, similar, but the directrix is now on top because, well, the parabola is facing the other way. In this case, your p would be negative because you're thinking you're subtracting from the vertex to get to the focus. So p is less than 0 would be going down this way. And again, here are the equations that go with that. For my sideways parabolas, these are a little interesting. You do have something similar, but now the axis will change into y. So normally our axis of symmetry is x equals some number. Now it's y equals whatever the y value is because, well, it's going sideways, yeah? So the parabola is it's backwards. Well, not backwards, but it's a different orientation. Okay, so in this case, when p is negative, you're thinking kind of to the left. The parabola will be facing to the left, and that's the space between your vertex and that focus point. And again, here's the equation that goes with that. And finally, if p is positive, well, the parabola is facing to the right. It's going the other way now. Okay, so yeah, that's basically it. There's really nothing too crazy about this. Let me go ahead and show you just this last part so you can copy it. And we're going to go ahead and start an example. We're going to go right into it. Let's go ahead and begin. Lots of stuff to copy, I know. Hopefully the video is not too long. We have example number 1. It says find the standard form of the equation of the parabola with the vertex at the origin and the focus is 0, 38. So first of all, what I'm going to do with this is I'm going to kind of sketch it just to kind of give me an idea of what I need to find. So I know that my vertex is at 0, 0. So this point is 0, 0. And I know that the focus is at 0, 3, 8. So I'm going to put a little bit high just because I want the room. We're going to say this point is 0 and then 3, 8. Okay. So my parabola might look something like that. Hopefully yours is nicer than mine. And we need to find the standard form of the equation. So the parabola is going upward, right? So what I would do is I would look at my picture over here and say, well, the one that's going up is this one. So I'm probably going to have to use this one. But I also know that my vertex is at 0, 0. So I'm actually going to look up here and say, well, this one is the one for 0, 0. So I'm going to use this one, x squared equals 4py. So let's do that. We're going to write that down over here, x squared equals 4py. And all I really have to find, I need to find p because I don't know what p is. If I have x and y, then we're good, but I need to find p. So how am I going to do that? Well, p is the directed distance between the vertex and the focus. So what I'm going to do is I'm going to figure out that distance. So remember this right here, this is our focus. I'm going to put F for focus, and this is the vertex. So P represents the distance between here, which shouldn't be too hard to see because you're going from 0 to 3, 8, so the distance is just 3, 8. Yeah, so all I got to do is plug that in. So I'm going to go ahead and say x squared is equal to 4 times 3, 8 y. So I did that right here. And then that's going to give me, let's see, I can divide that by 4, which would give me 1 over 2. So I'm going to end up with 3/2 y. And believe it or not, that's it. We're done. This would be considered our standard form of the equation because it's in the format that I wanted it. I want the x squared on one side and the y on the other. So we're done. Nice and easy. Okay, example number 2. So let's find the standard form of the equation of the parabola with vertex 2, -3 and focus 4, -3. So let's go ahead and graph it first. You always want to graph it first to see what does the parabola look like? Okay, so let's see. We have, let's do this like this. We have 2, -3. So 1, 2, 1, 2, 3. That's 2. This is -3. So here is my vertex, and then the focus is at 4, -3, so 3, 4. So it looks like this one is going the other way. So I'm going to label my focus with the blue color, F for focus and V for vertex. So this one goes maybe something like that, which means it's going to the right. Okay, so for the right side, I'm going to have to look at on the other page here. I'm going to look at the one that's going to the right, which is basically this side, the horizontal axis. And this one's not centered at the origin, so I'm probably going to have to use this one right here. Y minus k squared is equal to 4px minus h. Okay, so I'm going to write that down real quickly just to kind of, so we know what we're looking for here. We have y minus k squared is equal to 4p x minus h. And of course, p cannot equal to 0. We know that because, well, there's a distance between that, so it can't equal 0. So we're going to the right. So let's see. First thing I'm going to do before I even find p, I know that my vertex is 2, -3. So if I plug that into here, this is h and this is k. I can kind of get some of this. I can say that y is going to be, I'm sorry, that this part's going to be y minus, and then my k is -3, so I'm just going to plug that in there. And then we have 4p times x minus h. So we can simplify a little bit. This is going to be y plus 3. you want to think of it as opposites, you can also think of it that way. That's going to be the opposite of this is -2, opposite of that is +3. That's another way to do this. So we're left with this. So it looks like all we really have to do is find P, yeah? So I'm going to find P. How am I going to find P? Well, we're going to find P, which is the directed distance between here and here. So what is the distance between 2 and 4? Well, it's just 2, right? 1, 2. So P equals 2. Okay, so I'm going to plug that in. So y plus 3 squared is equal to 4 times 2, and then x minus 2. Y plus 3 squared equals 4 times 2 is 8. X minus 2, and we are done. Easy, because we want the standard form of the equation. So standard form is something squared and something that's not squared with our p, with our not the p-value, but 4p in front of the other one. Okay? So yay, second smiley face. Let's see how many smiley faces we can get this time. Okay, done. Moving on, example 3. Hopefully they're not too bad so far. Example 3 is going to be a little more difficult. Okay, so example 3 says find the focus of the parabola. Then we have this crazy looking parabola. You do have a note on top that says completing the square is required. This is a concept from last semester, so I don't know if you remember it. I'm going to do my best to kind of remind you how it works, okay? You'll notice that we have x equals, and then this is all in terms of a y. So the one that has x equals, just to kind of remind you, let me see. Well, it's not necessarily x equals, but if you look at these here, let me look at these ones. Um, if you were to, well, you know what? Let's work it out. Then I'll explain that part. That way I'm not confusing people. Let's go ahead and try this. We're going to have to complete the square to put this in the format that we want, basically. And once we find that, we can find the focus of the graph. So what I'm going to do is I'm going to write it out. X equals 1/4 y squared plus 3 over 2y plus 13 over 4. When you're completing the square, you don't want to have any denominators. So what I'm going to do first, I'm actually going to multiply the entire thing by 4 to get rid of all those denominators. And that's going to give me 4x is equal to 4 times 1/4. If you're thinking the 4's will kind of go away, so you're just left with y squared. 4 times 3 over 2, again, you can think of it like 4 times 3 is 12. 12 divided by 2 is 6, so that would be plus 6y. You could also think 4 divided by 2 is 2, 2 times 3 is 6, whichever way works for you. Plus, again, this one, the 4's will just give me a 1, so you're left with 13. And if you can't picture that, you can multiply it. 4 times 13 is 52. 52 divided by 4 is still 13. Okay. So there we go. There's the first step. We multiply to get rid of the denominators. Next, when you're completing the square, you always move the constant over. This one's, it looks a little more complicated because usually we have a 0 here, but you're still going to move the constant. So here's the actual completing the square part. We're going to move the constant, which is 13. So minus 13 is going to give me 4x minus 13 is equal to y squared plus 6y, because those are now gone. Here is where we complete the square. We're going to go ahead and we're going to add b over 2 squared to both sides. And maybe you kind of remember this now, because this is the magic part right here. So what is b over 2? Well, b over 2 is going to be our b value. So 6 divided by 2. And usually you get it from the beginning, but since the beginning would actually be this part right here. This is where you would get it from, but it turns out to be the same, so we're good. I wouldn't use this one because even though, since we multiplied by 4, we didn't actually change any of the values. We just made a factor of the original equation. So we could use the 6. So 6 over 2 squared is going to be, 6 divided by 2 is 3. So 3 squared, which is just 9. So I'm going to add 4x minus 13. I'm going to add that 9 to this side. And I believe I did it with a box last time I went over this topic. I kind of put a box and press it. We're going to add something to both sides. Okay, and then we're going to factor. Oh, actually, Well, yeah, we can factor, that's fine. So we can factor this side, right? It's going to be y plus 3 squared. On this side, we have to combine first. So I guess I should have made a comment about that first. And I'm not doing like an actual step 1, step 2, because we have done this before. So we're going to combine this first, which gives us negative 13 plus 9 is 4. So minus 4. And then we can factor this one now. So I can take out a 4. You can use greatest common factor, right? So it gives me 4 times x minus 1 is equal to y plus 3 squared. And I think we are good to go. This right here is our standard form already. What I would usually call vertex form, because you have the vertex, but I mean our textbook calls it standard, so we'll call it standard. From here, we can get our vertex, because our vertex will be 1, comma, negative 3. It's like saying minus 1, or this would be our h. Think of it like that. It's our h. And 3 would have to be negative 3 because it's y minus h. So it's just the opposite, if that makes it easier for you. So these are my values for the vertex. And we kind of sort of have the focus by getting the p. So let me show you. Let me show you something real quick. This format where we have something like this, I'm going to jump over to my other page real quick and show you that it's right here. Y minus something squared and then 4px minus h. That's exactly what I have right here, right? Y something squared and then 4x minus h. So that means that this 4 is where it's represented, it's where the p is located, but remember that this is 4p, so we're actually going to have that 4 is equal to 4p. So this number is equal to 4p. It's matching up my equation over there, okay? And if I solve, I get that p is equal to 1. Why is that important? Well, that's important because if I were to graph this, let me graph that real quick. 1, negative 3. And I know that this is a horizontal. It's going to have a horizontal axis, which means it's going sideways, right? Because that's what this one up here. Remember, it's matching this one, so it's gonna be one of these two right here, one of these two graphs. Since my p is equal to 1, that means that it's greater than 0, which means it's gonna go to the right. Okay. So back to this, it's gonna go something like this. And since it's going 1 to the right, that's where my focus is going to land. My focus is p units away from the vertex. So what point is this? Well, this is just going to be 2, because that was 1. It's going to be 2, negative 3. And I have found my focus. Little more difficult, little more steps, but you know what? It's not too bad. Okay. One more example. I'm not sure where we're at on time, but we do have to do this last example. So one more example. A couple things to copy real quickly. First, we have another definition here. A line is tangent to a parabola at a point on the parabola when the line intersects but does not cross the parabola at the point. So this one is best taught with an image, because I know that sounds kind of weird. And believe it or not, this is actually a calculus concept, which I am usually super excited about, but I think it's easier doing it with calculus, but you'll get there. We're going to do it the conics section way. So here we have this reflective property of a parabola, and it basically says that this tangent line to the parabola at some random point, so we just have an arbitrary point, we're going to call it P, it makes equal angles with the following two lines. The line passing through P, so I'm sorry, P and the focus, so think of it like this right here. So this line right here makes some angle, okay, together, these two. And then the axis of the parabola. So this is the axis of the parabola, and you kind of see this like isosceles triangle. This is an isosceles triangle. These two angles are the same, which means these two sides are the same. So we can kind of say that distance 1 and distance 2 are equal to each other, okay, and this is the distance. I don't want you to confuse it with the directrix. Going back to the tangent line, because that's kind of like I kind of just went over it. The tangent line represents this line, and I actually drew this line using my paper. What I did is I picked a random point, and then I just kind of folded my paper, and I said, I'm going to try to make this line to where it's only touching at that one point. So you'll notice that it's not touching any other point on the parabola. It's a pretty accurate representation. And what it is it's a line that will only touch at that one point. To kind of give you a heads up on the calculus part of this, we use tangent lines to find the slope of a point of a parabola or of a graph or of a curve or whatever we're graphing. And if we were to find all the tangent lines for every single point, put them together, and you get your curve. Kind of cool stuff, yeah. But we won't go too much into that. Let's do the problem real quick, and then maybe we'll talk about it in class. Example 4, it says find an equation of the tangent line to the parabola y equals 3x squared at the point 1, 3. So I'm going to start by graphing this because that's the best way to do this. We're going to graph, or sketch, I should say. We're going to sketch this. Y equals 3x squared. I know that this one has a vertex of 0, 0 because, well, that's the format that it's in. There's nothing else. There's no parentheses or anything. So I know that my vertex is going to be right here at the center. Let's pretend this is x and this is y. I also know that there's a point 1, 3. So 1, 1, 2, 3. So there's my second point, and the parabola probably does something like that, since that's my other points. Okay, I want to find an equation of the tangent line to the parabola. So what I'm going to do first, I'm going to kind of try to construct this tangent line. How am I going to do that? Let me see. Let me get my, just going to grab my phone here and try to do my best to get just cross that point. And if it doesn't come out that great, that's okay. You don't have to be perfect. You know me with math. I like to be as accurate as possible. So we're gonna just kind of do this. All right, and it looks like it's kind of there. And what I need to find is my focus also, because I need to know that this basically has to connect to the focus as well. Okay, so for me to find this equation, I need that point. So let's go back a little bit. You know what? I think I might. Let me give you some stuff here and we'll finish this one in class because I do think we're over on time. So I'm going to label this point right here 0, comma b. Why am I doing it like that? Because I know that just an equation of a line, okay, an equation of a line, just a regular line is y equals mx plus b. Now back to like algebra 1. So that means I need to have a slope and I need to have a y-intercept. This is the y-intercept, so I need that point for sure. The slope, well, I know that this point up here is 1, 3. I know that slope is equal to the difference of the y's divided by the difference of the x's, right? So if I could figure out what this point is, I can use this and this to figure out the equation of the line, okay? How am I going to do that? Well, I'm going to find the distance between here and the focus. So we need to find P so that we can find the focus, so that we can find the distance between the focus and 0b. Because if I can figure out the distance between here and wherever my focus is, I can figure out this distance and basically get my points that I want, okay? So I'm going to go ahead and stop there. We will finish this one in class. And by the way, there is a presentation based on this one, so please make sure you pay attention when we get there. Thank you guys. Have a great rest of your day. If you have any questions, just let me know.